Hello and welcome to Geometry with Mr. Clausen. Today we are going to get started on BPP 6, which is our electrical contractor activity in this series. And as part of this activity, we're going to look at how to plan the electrical layout of a floor plan, which is going to include things like outlets, lights, light switches, all according to building codes, and then also practice calculating the square footage of cabin plans 1 and 2. And so a big thing that we're doing in this and the skill that we're learning here is that how do we take a floor plan and then lay everything out, switches, electrical lines, lights, all that information, so that when an electrical contractor comes in, he can purchase all of his wiring or her, the outlets, the switches, and all the materials needed to fully wire a house. And how to do it in a way that's efficient, because sometimes, you could go and place an outlet every 2 feet, but that wouldn't be practical. So we want to do this in an efficient manner, and that's what we're going to do today in terms of this activity. If you took this in class, you would have been handed 2 floor plans. One that I'm going to work with you now, cabin 1 floor plan, is going to be the one that I work through in this video to show you how to do this activity, and then cabin floor plan 2 will be the one that you are assigned as your homework. So some key things to keep in mind here: light switches are indicated by a $sign, and if 2 switches go to the same light, those switches need to be wired to a 3-wire electrical line. And so how you indicate that is you do a $sign with a 3. This is used whenever you want to have multiple points of entry. Lights are designated to a switch using dashed lines. We'll look at all that. We'll talk about these building codes again. These are all things that we've talked about in BPP 5, as well as some other activities as far as, that you need to have lights in your hallways, your stairways, your porches, any living area with the exception of the living room. And kitchens should have lights near the sink and the stove as overhead lights, and those should have switches next to them, which should be located either next to the thing or to the door of the room. Some of the things that we'll talk about with 3-phase wiring, this, if you missed class, I will talk about this briefly, but really all that 3-phase 240-volt electrical outlets are outlets that have 3 wires, 1 neutral, and 2 hots, while a normal outlet only has 1 neutral and 1 hot wire. All right, and that's where the term 3-wire and 2-wire come into place. Now, all these still have a ground wire involved with them, and I'm not going to get into a huge amount of detail in this video about it, but when we get into drawing this out, I will show you how you indicate a 3-phase or 3-wire 240-volt outlet in comparison to a 2-wire 120-volt outlet. And with that, as we're going through all this, we'll place all our 120-volt electrical outlets that are up to code in a reasonable number. We'll place 240-volt electrical outlets behind the things that would typically need that. So if your stove's an electric stove, we'll need to put a 3-wire 240-volt electrical outlet. The same will go for a dryer and a water heater. And those are the only 3 things in your house in this day and age that should need a 240-volt electrical outlet. And if any of those are going to be ran on natural gas or propane, then you would kind of segue away from those. But in terms of the activities that we're doing here in this project, we're just going to deal with everything electric, because we're not going to learn how to do those type of plumbing diagrams and those type of things. We'll place lights, we'll place switches, and then we'll determine the square footage of the floor plan within 5% of the correct value for full credit. So those are some of the things that we're going to look for in this particular activity. So without further ado, let's get to the blueprint here and talk about how we lay all this out. So I'm going to draw all these. You'll need a ruler for the square footage calculation, and you'll need a template for the outlets and those type of things. And typically how I get started with something like this is I just start at a corner and I just start working my way across placing all the outlets. Now, we want to be efficient. We want to place outlets and such where they need to be. And so what I'm going to do is, if I start in a corner like this, where do I want outlets, assuming that this is the layout of where things are going to be? Well, I want an outlet behind the refrigerator, right? Like you want to be able to power that. And so refrigerators require a 2-wire outlet. You're going to see I'm going to draw 2 lines there. And then I'm going to draw that circle using my architectural template. We want this to be neat and clean as far as all that layout. So that's an outlet. Now remember, for countertops, we've talked about this as well, is that, you know, no space along a countertop can be further than 2 feet away from an outlet. And so all this countertop that I have here, I'm going to need to place, you know, some outlets. You know, this is so we have access to electrical wiring for coffee pots, blenders, food processors, you know, whatever else you may have. And so let's start laying out all of that. And, you know, I'm going to start putting stuff here. And actually, how long is that? Is that an inch? That is an inch. So, you know, what I'm going to do here, I actually don't want that outlet there. That's part of doing this in a more efficient manner, is I don't really want 2 pairs or 2 outlets there. So I'm going to place this right in the middle here. That's the 2-foot mark. And again, the reason I'm doing this is if I place an outlet here, this area along the countertop, this 2 feet will be covered by an outlet here, and this 2 feet will be covered by an outlet here. So if I strategically place this outlet in the middle of this 4-foot section of countertop, then this would be to code. And more doesn't always mean more. I'm going to stress that you don't need to go stir crazy with the number of outlets that you have here. Just simply because, you know, we're going to have one here on this side of the window, and then draw the circle. And then we'll have one over here on the other side of the circle. These would probably be GCFI outlets because they're next to water. And now we're all set in the kitchen as far as our 120. Now, one of the things I want to point out here is that you notice with each of these outlets I have 2 lines. And this is indicating that this is a 2-wire 120 volt outlet. That's what the 2 lines refer to. Now, a stove should have a 3-wire, all right? And the only difference between a 3-wire and a 2-wire is that a 3-wire outlet has this extra red wire in it. So normally you have a white and a black wire, one being your neutral, one being your hot. The black wire is usually your hot wire. And with the 3 wires, you get this extra red wire that's either your traveler wire or it's your extra hot wire. And that's how you get the extra 120 volts there to power those things. And so stoves require a little bit of juice. So what I'm going to do here is I'm going to draw the 2 lines that I typically do. And how you designate it for an electrician is that you go and you draw a 3rd line between the other 2 lines. You draw this 3-line sketch here, and then you take the circle and you draw that there. Now here I have 3 lines, and this represents the 3-wire, which is part of the 240 volt outlet. And if you ever buy 3-wire, or you have like wire from like a hardware store or Menards, Home Depot, anything like that, and you buy a 2-wire chunk of wiring, you'll notice that they have 3 wires and 3 wires have 4 wires. And the reason for this is that, you know, all of these electrical cables that you run have a ground in them, and it's just a pure copper wire with no coating or anything on it. It's usually just insulated with a little thin layer of paper. They don't count that wire when they're talking about, you know, something being a 3-wire and a 2-wire, because all the ground is just giving the electrical system that spreading capability to stabilize it if you ever have a surge or anything like that. Just in a real simple explanation. And so this is how I would wire everything in the kitchen in terms of, you know, your outlets. Now your switches, you know, it says that you should have lights over the stove and the sink. So, you know, if I wanted a light by the sink here, I would actually just go and draw a $, freehand here. And then normally what I do for a light is you have this thing here. This is your typical light icon. And I'm going to go and I'm just going to draw this thing here. And that's going to be my light. And then I just draw this dashed line. And voila! I have a light switch indicated with wiring for that light, and then the position of that actual light above my sink. And I'm going to do the same thing for the stove here. And actually, I am going to make sure that I have this oriented the way I want it oriented. And actually, do I want it oriented this way? Yeah, let's orient it this way since we have the diagram down here. So I'm going to do the same thing here. And we'll go again, set up another light. And we'll go and we'll draw that there. And now you have a light switch with a light above the stove. That would be something that you would typically want. And if you want to do fluorescent lighting, everybody has a little bit of different opinion about that. So if you want, like, 6-foot fluorescent lighting, I don't mind that at all. So typically how I would go draw that out. So let's say you're going to buy those. Let's do the 4-foot bulbs because the 6-foot stuff's just unbelievably expensive. Honestly, the 4-foot stuff's bad enough. And so if you want to go and you want to draw 2 4-foot bulbs, typically how you draw this, like on a blueprint, is you just draw these straight lines, and then with these book things, like end things, sort of like a line segment. And then if you want to have a switch for that light, if you're walking to the kitchen, what is your typical path going to be to get to the kitchen? You go this way, and then you go straight in, you go over here. So maybe we put the switch, it's really up to you where you want to put the switch, but maybe I'll put it right here. So I'm going to go and I'm going to put the switch right here. All right, and then what I would do, and if you want to put the switch in a different spot, I'm not going to argue with you about that. I mean, this is your design. This is your electrical layout. And so if we put the switch here, I'm going to draw a dashed line indicating that, the switch has power, and it's going to bring power to that light. And then if you want 2 lights to be powered by the same switch, I would just daisy chain it like this. And I'm just looping it around a little bit to clearly indicate that, power's going from here to here and then from here to here. And so both of these things would be powered by that switch. Okay? And that gives us a nice little layout as far as indicating all that. Now, we have our dining area here. So this, again, we could just put, a nice light here. Actually, I'm just going to draw the circle first, and then use this to draw the lines. That looks a little bit cleaner. And, and so typically I would have a light switch here, and then run that wire there. I feel like I only need 1 switch to go to that light. Now the living room doesn't technically need lights. I tend to feel weird about that. So there's a couple things I'm going to do here. I'm going to put a switch here, and this switch will be, actually need 2 switches here. So the reason I'm going to need 2 switches here is I need 1 light on the porch here, because every porch is required to have a light. That's one of the building code things that they go and establish here. So let's go, draw our circle, and then use this diagram to go draw our lines. Have our nice light there. So we'll take this switch and just draw that dashed line. That switch is indicating for that. Now, this line here, I'm just going to go put some lights in the living room. We'll space this out in kind of a nice hall format here. Let's do like 4 lights. So, if we do one there, do one there, And let's go on the other side of the fire pit. And again, we're just practicing laying this out. And then I'm going to move that out of the way there for a minute. Boom. And we're just going to draw all these out. So we're going to keep tracing out these lights. Alright, so now what I'm going to do here is I'm going to take a switch next to the door, because that's specified in the building codes a little bit here on our worksheet, that there should be a switch next to a door that turns on the lights for a room. Now again, the living room isn't mandatory in terms of lights, but you know, again, I feel like it makes sense. So I'm just going to trace out the wiring here. And what I want to point out here is that this switch goes to these lights, and that when you enter through this door, you can turn these lights on. But I feel like there should be a switch over here that can also turn on these lights. And so what I'm going to do is I'm just going to do a quick rotation here, and I'm also going to put a switch here and connect it all to this light over here. Now, an important thing to keep in mind is that you can't just attach as many switches as you want to lights, because if you think about like lights, they need power, right? And if you have it on one side and off here, let's say, well, where's the power coming from? Who's controlling what? And so how you can bypass this is you can use a 3-wire electrical line, you know, where you have the 3 wires into the ground, and you can install what's referred to as a 3-way switch. So what you do with a 3-way switch is you only have one hot, and the red wire becomes a second neutral. So sort of like with the stove, where the red wire becomes the second hot, you can use a 3-wire over here and use the 3rd wire as a second neutral. And all that this does is that if you have a 3-wire, part of the reason you need to indicate it here is you need the electrician to know that he needs to buy 3-way switches and to buy 3-wire lines to connect to these lights. So that when this is all coming together, we can put this in. Now, whenever you're doing this, the max that you can do is 2 switches to one set of lights. So that's something to be careful of. Don't think you can go $3, $3, $3, and put 3-way switches everywhere and think that it's going to work. There are a little bit of limitations here, but you can at least get 2 switches onto one set of lights, which is a very useful feature. All right, but whenever you're doing a 3-way switch, when you have 2 switches going to one set of lights, you have to use a $ with a subscript 3 on next to it, because it lets the electrician know he needs to use 3-way switches and to get 3-wire electrical lines to connect to these lights. So something to just keep in mind. So we have some basic lights going on here now. I think what I'm going to do over here is I'm going to put a switch here. And what that's going to allow me to do is put a light in the hallway, because we know by code that that is required. So we're just going to put a little bit of a light here. Ooh. And get this all going. So we got a light. Just draw the line so you can clearly see that there's a line going to the light. The bathroom is in need of a light as well. So let's just go put it right in the middle of the bathroom here. So, and we could actually do 2 separate lights if you wanted. You could do one above the sink and one in the middle of the room. We don't have any designation for things like fans, but you know, there's nothing preventing you from doing that. Most experts know that that is required to code to have a fan. All right, and so let's go. Let's put the $ switches this way. So we'll do 2 switches. We'll have one that's designated towards this light, one that's designated towards that light. And you hopefully can see how this is very clearly laying out, like, hey, an electrical contractor should be able to pick up this blueprint and know exactly how many light switches of what type, how much wire of what type that they need to get to complete all of this wiring. All right, because light switches, they usually use 16 gauge wire for a lot of lighting applications, and I believe 12 gauge wires a typical type of wire that you would get for an electrical outlet application, depending on the amperage you're running through it. And so these are all things that we can indicate here. So now that we're to the bedrooms, I'm just going to finish the lights so we can conclude that part. I'm going to put a switch there and a switch there. Let's get one in each room. Let's put a light in each room. This takes a little bit of time, but we'll have this video and we'll have a little bit of time to put it together here. And again, as far as the lighting and the spacing, it's kind of up to you how many lights you want to use. You know, in terms of this application, you know, most bedrooms like this, if you get like one ceiling fan type light, you're good. You can see I did 4 lights here. You have windows to bring in some natural light, so that definitely helps. If you don't have any windows, that's usually, you know, a good reason to do more lighting. Like, I think about the office I'm sitting in right now, and you know, it's probably about 12 by 17 feet, and I actually have 9 can lights in this room to just kind of light everything up, plus outlets for my desk for a desk lamp and that type of thing. You know, so depending on certain variables, you might want to take those into consideration. So we have all the lights. I do see that this porch needs a light, so let's get one additional switch in over here, because that's a safety concern thing, is to have a light on your porch. So let's just put, I don't know, we could do 2 lights. We could do, you know, maybe we just set it up so that there's multiple lights going to one switch. That way, if your dog's barking and there's a bear on your porch, you know, you can clearly see it. Granted, that'd be really scary, but you know, depending on where you live, like, that might be your reality. But let's go. Got all that, and then obviously make sure to draw your lines. And again, this can just be freehand. Exactly how I'm doing this is how I'd expect you to kind of trace all this out. And again, you can see this one switch connects all of these lights. And now, for the most part, in terms of your layout, you have your building codes met. You have outside lights, you have lights above the sink and the stove of all your different rooms. Everything's pretty well distributed. And then as far as light fixtures goes, you could just tell your electrical contractor the type of light fixtures you want, or if they're just leaving it there and you're doing that yourself. I mean, it just kind of depends on the specific circumstance. That's there. I see this window doesn't have any markings on it, so maybe we should identify, this is a 4-foot wide window, so maybe we should just label this window. Those type of things, kind of like, those should be there as far as building codes go. All right, I'm just going to finish that. So now we have all the lights in place. So now the next component would be to figure out where all the outlets would go. We did this part here, and I'll go through the rest of this so you can see this all lay out. But you know, I'm looking at this section here. There's over 12 feet here, as you can see, to go from like the refrigerator to what's going on here. So I am actually going to place 2 outlets here, just simply because This one would be more designated for the kitchen. This one would be more designated for the dining room. And like I said, since it's over 12 feet, we can't cover the whole thing with one outlet. So I am going to do that there. It might seem just a little bit more than what's really needed, but you also have to be to code with that general layout. So go lay out some of these. This wall is longer than 2 feet, so let's get that laid out. We'll get an outlet over here. And now we just need to draw in those circles. And again, I don't think this is necessarily hard. You just have to think about it a little bit and just kind of check some measurements. This wall is longer than 2 feet, even the area behind the door. So let's just go get that identified. None of those walls really work to get anything on, so we'll just make sure for that hallway, you know, there's a couple outlets reasonably close that are accessible. And now, how long is this segment? This again is over 12 feet, so I really have to do 2 outlets here. And I mean, having a few extra outlets is fine. What I really want to avoid, and I've seen students do this in the past, is, you know, they worry that they're going to fail the electrical outlet requirement because they don't understand the 12-foot component. The idea that, you know, if you're here, are you at least 6 feet either way from an outlet? And so what I've seen students do in the past is they literally put an outlet like every single 3 feet apart from each other, and that's a lot of outlets. I mean, it gets to a point where, you know, if you're even thinking about the material aspect of it, you know, you're talking, you know, an extra $10 for each outlet that you're trying to put in. And plus you have to hire someone to cut the hole in the wall material and the electrician to put it in and all these other things. And so, you know, you're creating a lot more work for yourself by requiring all those additional outlets. So put what you need, but definitely don't go crazy over it. And now the chimney here, now you could say, oh, that's more than 6 feet of wall space, but you can't really put an outlet in a chimney. There's definitely some safety concerns there. So that is really all we need in terms of outlets and where they are being placed. And now what we're going to do is, again, these walls are shorter than 2 feet, so we don't need an outlet there. Let's put an outlet in the bathroom here. Get this sink acquainted with a setup for the blow dryers and such. And now let's do the bedrooms. Now what I am going to point out about the bedrooms is, once I measure the walls, 10 feet, less than 12 feet. Okay? So when I'm doing these, let's see, is this wall's right at 2 feet. I believe an outlet does not need to be placed there. According to the code, it says at least 2 feet in length. That's right borderline. If you're worried about it, I won't dock you points if you forget to put an outlet there. I don't think an outlet needs to be there as far as that being part of the closet. If you want to put one there, I won't stop you. But to my knowledge, you don't have to put it there and it still be within code. If someone knows differently, feel free to leave shoot me a message or leave me a post in the comments. But when we're going through and we're trying to set this up, again, all these walls are less than 12 feet. So now I'm just aiming for about the middle of the wall. Make sure those are fully connected there. I guess I need to go just a little bit further back. I'm not quite touching the wall with my lines. You can see that that bedroom is now done. let's get this guy going over here. That one's all set. Again, just aim for the middle. You know, you have about a foot either way of leeway here, so unless you really need to be intentional for some reason, which is fine, that's your decision. But as long as you have an outlet on each wall, that is all those bedrooms should need to be up to code. Now, there is no dryer, and there is no water heater in this floor plan, so we don't need to worry about drawing in these 3-wire outlets for those. If those are present, you should put 3-wire outlets there. But in terms of what's expected for this assignment, you know, as far as the grading criteria, all of your 120 volt outlets are to code in reasonable number. Your 240 volt electrical outlets for the stove, dryer, and water heater, well, there's only a stove, so that's present. Placements lights are up to code and in a reasonable number. I think the biggest thing that I could see students accidentally missing, like in relation to this floor plan, is probably the porches and the hallways. Those are things that definitely are needed there. If we wanted to exclude those lights, you could technically get away without having those, at least to my knowledge. Placement of switches that are reasonable to place with clearly designated dash lines indicating where they go. Good. And so now the last part of this assignment will be determining the square footage of your floor plan. So I will, just to go through it again, do the square footage here so that you can see it. If you feel good about what you are doing about your square footage calculation, you can stop the video in just a moment and continue on, because what you will be doing for this assignment is you'll actually be going through the cabin 2 floor plan. So it's very similar in nature. There's some porches, bedrooms. There's a lot of very similar aspects of this blueprint in relation to this one. So what you will be turning in for your homework is this blueprint with the lights put in place, the outlets put in place, switches, dash lines, all those types of things. So this will be what you will be completing for your assignment that is graded to demonstrate your knowledge. So if you feel good, feel free to stop the video in here and move on. If you want to see a square footage calculation again and you're just like, I want to see that one more time, hang tight and we'll do that together here. So what I'm going to do for a particular situation like this is I'm going to start splitting this up a little bit. So if you're trying to figure out what the square footage of this should be, you know, I'm looking at here to here. And this is 4 1/8 inches. So this is 16.5 feet in terms of what the scale is, because 4 feet for every inch, the extra 1/8 inch is a half a foot. And so what I'm going to do now is I'm going to try to sketch some lines here so that I know where some basic boundary lines are. I'm going to go here and also draw some additional boundary lines here. And again, I'm just applying the concept of area addition postulate and just figuring out what squares are at my disposal here. And just split it up into few number of squares as possible. So this square here is the first one I'm kind of calculating out. This is 16.5 feet by 12.5 feet. So it's 12.5 feet this way. Okay, so that's the 12.5 is the length of this wall. 16.5 is the length of that wall. And so what I'm going to do here now is I'm going to get a calculator up here and go 16.5 times 12.5. This will give me a square footage of 206.25 feet square. This square here is 8 feet by 8.5 feet. So this square is 8 feet by 8.5 feet, or 8.5 feet. So 8 times 8.5, this is equal to 68 feet square. Okay, so you have your entryway, you have your kitchen dining area. Now, this area, ooh, this is 8, 9, 10 and 1/2. I know it's hard to see on those paper things, but by, ooh, I don't really want to say 16, so I'm going to say 15.75 or 3/4 feet. So 10.5 times 15.75. We're just replacing those fractions with decimals. So the area of the living room here will be 165.375 feet square. Now the chimney, that's 2 feet by 6 feet. So this is an additional 12 feet square. And now we only have one other area here. This is, it's between 12'3" and 12.5. I'm going to say 12.5 there by 24, 25, 25.5, 25 and 3/4 feet. Again, you're kind of in the middle of those two 16ths. I'll allow you to make a judgment call to the nearest 16th. I don't need you to do super crazy decimals, at least for these assignments. Okay, so the area for the 2 bedrooms, the hallway, the bathroom is going to be 321.875 feet square. So now, again, for the square footage, all you need to do is take that number, add it with 68, add 165.375 plus 12 plus 206.25, 206.25. And what you should get is 773.5 square feet. And so if you've done this before and you got a little bit different number, don't worry. Like, there are situations it's really easy to miss some of these basic numbers, some of these basic calculations. You're off by one little thing. So I give you a little leeway as we're going through this. But this is the square footage that you should be aiming for in this particular project. So with that said, I'm going to leave you to it to go back to cabin plan 2 and to do some calculations, find the square footage of this plan, and figure out where to place your outlets, your light switches, your lines, and your square footage. So with that said, let's do some math.